Welcome to the Sci-Cast, the show where we discuss all things science. I'm joined by Harry.
Hi.
Zaynah.
Hello.
And the mysterious Dr. X.
Down.
Today we discuss space travel with paper, falling cats, a human cell atlas, and a mysterious void within our universe. I'm Max, and this is the Sci-Cast. So have you all guys got your pieces of paper with you?
Yep.
Yep. All right. So your challenge, should you choose to accept it, is to fold that piece of paper as many times as you can and as quickly as possible and make sure it's neat. Ready, steady, go.
It's frantic.
It's right.
I'm trying a careful strategy.
Oh, you're going the neat route, the quality over quantity. Oh, let's see that again, Harry. Perfect. How many times did you fold it?
This is 6 so far.
6. Nice. Okay. What about you, Zaynah?
I'm also on 6.
6. Can you get more than 6?
No, really struggling.
With difficulty, I don't think so.
No. Dr. X.
I'm on 5.
You're on 5. You can't get 6.
I'm trying.
Right, go on. All that might, all that strength.
If that counts as 7.
Yeah, I'll take that. As a human doing that without a machine, I'll take that. All right. So how many times with an A4 sheet of paper is it possible to fold it without it breaking? Does any of you know?
Isn't it 11?
Not 11, it's actually 7.
Oh.
Yeah, so you did pretty well. You can't really fold it more than that without it breaking. My next question though is, if you could fold it as many times as you wanted, how many times would you have to fold it for it to reach the moon?
42?
42?
Yeah.
Well, how far is the moon away? Something like 239,000 miles. You think it's 42?
Pulled the number out of, I think I remember it from somewhere.
Okay, what from Monty Python?
Maybe actually.
What about you, Harry? What do you think?
I know it's not actually as big as it would seem.
Yeah.
Wait, to fold.
I'm going in the hundreds.
Okay.
I have no idea. I'm gonna go with hundreds, like Harry.
Okay. Well, I can actually tell you that it is 42 times.
Let's go.
And I really should have foreseen this. I was expecting, the typical answer of thousands. In fact, though, 42 times would actually overshoot the moon by something like 28,000 miles. So obviously you can't fold a piece of paper like 41.8 times. That'd be ridiculous. You can only fold it an integer number of times. So yeah, 42 times would be the number. And why is that? You sort of alluded to this before.
Oh, right. Yeah, because I don't know how thick a piece of paper is, but I guess if you fold it 42 times, you're going to have that thickness to the power of times 2 to the power of 42. That's insane.
Yes, you're absolutely right. It is the thing called exponential growth, which it is basically doubling its thickness each time you fold it. And yeah, you actually mentioned the correct formula to work it out. I was actually going to ask for people to try and work it out, but no, you've got it spot on. That is literally the magnitude of exponential growth, and it's quite hard for humans to comprehend exponential growth. There's one inherent problem, other than the fact that it sounds pretty delusional to try. What is the problem with folding a piece of paper that many times?
Well, what size of paper are we talking about?
Yeah, it's a good question. Say you stuck with an A4 sheet of paper. Other than the fact that it becomes harder to press it, what other property of the paper changes as you fold it?
It becomes a lot more thin.
What do you mean by that?
As in, so the size, it's X and Z size on those values will be absolutely tiny, because as you keep folding it, it halves.
Yeah, you're absolutely right. It's with I said the area of the paper, I think. That halves each time you fold it. And so if you were to fold a piece of A4 paper 42 times, the area would end up being, I've got this number here actually, 0.00000000, and I've lost complete track of what I'm saying. But in layman's terms, it would be smaller than the size of an atom.
Oh
So,
my.
yeah. So other than the fact, yeah, that's probably the reason that scientists haven't tried this. But there is actually quite an easy fix to this, theoretically, although logistically it'd be a complete nightmare and a complete waste of time. But if you actually increase, I think Zaynah, you were coming onto this. You asked what the size of the paper is. If you have a larger piece of paper, then you can get a bigger size towards the end. So if you wanted to end up with air, and say you folded a piece of paper and you wanted the top of the paper, once you'd folded it 42 times, to be say a 1 meter square, to have the initial size of the paper will be quite big. In fact, it will be 1.3 times the size of India. So,
Whoa.
yeah, I think we can fairly clearly conclude that this probably isn't the best way to get us into space, shall we say? So, my last question though is very interesting. I think. How many times would you have to fold a piece of paper, same thickness as A4, if you wanted it to be larger or as large as the observable universe?
That's going to be massive.
Yeah.
No, but then again, to be honest, I have no clue.
I mean, obviously, I think the observable universe is something like a radius of 50 billion light years, which is obviously that. Yeah, go on.
That's an absolutely insane distance. But you're also doubling each time. I'll say probably something like 150. That's what I'm going to go.
You're going
I feel
150.
like that's more. But if it's doubling each time, I'll go with something like 150.
Okay. What about you, Zaynah?
I'm going with 1,000.
You're going with 1,000. And you, Harry?
I'm gonna go with. I'm gonna say less than 100 actually.
You're going with less than 100 for the size of the observable universe.
I'm trying to work out whether this is gonna be like a trick question or not.
I can understand why you think that.
Yeah, I'm gonna go less than 100.
Okay. Well, I can tell you it's actually 103.
Ooh.
Ari, I think you underestimated a little bit, but you're pretty good, I'd say. Yes, it's 103 times. And Zaynah, I completely do not blame you because the observable universe is humongous. And I mean,
I had to give a bit of a variety.
Yeah, even I disagree that it can be like this, but apparently it is. 103 times for the entire observable universe. So, yeah, that is exponential growth. We now move away from the world of writing paper to the realms of falling cats. Zaynah, the floor is yours.
Thanks, Max. So today I'm going to be debunking the seemingly simple theory that cats always land on their feet. So I'm sure you've all heard of the saying, it's quite familiar, but how many of you can confidently agree with the statement? And do you know why?
Well, I have 2 cats and one of them actually fell out of a roof and he broke his leg.
Oh, wow.
I mean, he didn't break it, he didn't damage any internal organs. So I would presume he fell on his feet, but I don't think we can say his feet saved him. And my cat is a little bit clumsy, so I want to say it's true because it's a cliche, but no, I don't think so.
Great. Harry and Dr. X?
I don't have a cat, so I'm not too sure, but I feel like if it's true, it's going to have something to do with their center of gravity.
Yep, interesting.
I think I saw a video on this a while ago, but I absolutely can't remember it for the life of me. But I think probably there are 2 things which would have an impact. I think one would be like center of gravity, like Harry said. But I also think the other thing would probably be like, depending on how far from the ground the cat is, maybe the cat's got like an instinct to like change its positioning while it's falling.
Okay, yes, you've mentioned something there. So what I was going to say was I'm not going to suggest that we all throw in our cats on the floor, but I can explain some of the facts that we already know. So cats seem to be much better built than humans in this regard. They have sort of an inbuilt balancing system called the righting reflex. And this actually allows them to orient themselves the right way around and land safely on their feet. That being said, like Max said, it actually isn't the case that they always land on their feet. And like Dr. X said, the height of the fall is a key factor here, but I'll come back to that later. So the exact mechanism has actually kept scientists arguing for over a century. A cat needs to turn around, but to do that, it has to push against something else, but there's nothing there. And this is all to do with conservation energy, really. So as you know, in every physical process, momentum must be conserved. So this is a video from BBC One's Life in the Air, and it actually shows some extraordinary footage of how flexible cats, like the caracal, can actually twist their spines in opposite directions at the same time, so effectively pushing against itself. And not only this, it pulls its front legs closer, which makes the front half of its body spin faster, like a kind of pirouetting ice skater.
Oh.
So you can see this creates a twist in the spine, allowing it to swing the back legs round and prepare it for landing.
Oh, so like, I think is that like ballerinas when they want to spin really quickly, they bring their legs in and that causes them to spin faster?
Exactly.
Yeah.
So another key thing to note here is that cats reach their maximum velocity at around 60 miles per hour, which is much slower than humans at about 120 miles per hour. And once they reach this stage, they can kind of relax and stretch their legs out a bit more, much like how a flying squirrel does. So this will expand their body size and increase the drag resistance. So now, if we look at the image, so this is an illustration of the bend and twist model, and it's fairly simple. It shows the model of a turning cat, and I want you to imagine the cat as fundamentally consisting of two cylinders. So one is the rear half and one is the front half. And now if it bends at the waist, it can then twist the two halves of its body in opposite directions, causing their opposing angular forces to largely cancel. And then when it unbends, its body will orient itself in a different direction, even though the cat had no angular momentum to start with. And of course, the cat also has a few biological advantages. So the vestibular apparatus, which is kind of the system inside the cat's ear, which is used for balance and orientation, this will enable the cat to quickly figure out which way is up and rotate their head instantly so the body can follow. And as seen in the video, they also have an incredibly unique skeletal structure. So they have no collarbone and a very flexible spine with 30 vertebrae. So my fun fact, or what I found really interesting about this, was how the height of the fall affects the landing. A study was done using the vet records of cats that had fallen from multi-story buildings, right? And the cats who fell between 7 and 32 stories actually suffered less injuries than those who fell between 2 and 6. So obviously it's believed that they had more time to kind of right themselves. But regardless of this, most of the cats in this study landed on concrete and 90% of them survived, with only 37% needing emergency care. So Max, how was your cat now? Is he alive and well?
He properly broke his leg. I mean, he fell from pretty high up, like it was a good 30 feet or something. So, but
Wow.
I mean, I didn't see, I actually saw, I was in the lounge below and I saw him hit the ground. I saw this black, because he's a black cat, black and white cat, and just hear this black object, bang, smashing down onto the floor. And I think it did look like he fell on his feet because he broke his legs. So I assume they probably absorbed the blow. And, other than breaking his legs, which we had to trap him in a room for like 6 weeks, which was a nightmare. But The rest of him was fine. So I think he did land on his feet, and probably because he was so high up, like you said, his feet probably absorbed the blow.
Exactly. So another example was a cat that fell a whopping 32 stories and landed on concrete, and it was released after 48 hours with only a chipped tooth and a minor lung puncture. So yeah.
Wow.
And yeah, so this is all well and good, but can we actually learn anything from this? I hear you ask.
Yeah.
So in the late 1960s, this problem became of interest again because NASA wanted to teach its astronauts how to turn over in a weightless environment. And they've kind of made a computer simulation which refines this bend and twist model. Unfortunately, we don't actually know if this was attempted in space, but nowadays this research is being used more in robotics. So roboticists often turn to nature to inspire building better robots. And this falling cat might be able to provide a strategy so that a falling robot can land on its feet, minimizing any damage it might otherwise suffer. So in short, in reality, cats are stubborn and they do like their secrets. And nature will just use the most effective solution to survive, no matter how complicated. And the writing reflex still remains a mystery to many scientists today.
Wow. That's amazing, Zaynah. Thank you so much. And now to something completely different. Dr. X talks about a human cell atlas.
Right, so just to start off with, this might be like a nerdy question, but what is your favorite type of cell? And I don't mean power cells or batteries. Let's think human body and the fundamental unit of life.
Well, I haven't
Mitochondria.
gone.
I'm going with mitochondria.
Mitochondria. That is a bold choice.
I haven't done biology since year 9.
That's an organelle. Oh my god.
It is an organelle, yeah.
Yeah.
It did come from it did used to be its own organism though, so I'll accept it. What do you like about the mitochondria? Mitochondrion.
I think that it is essential for everyone, and I also just like the name.
It is a cool name. Powerhouse of the cell. Okay. Any others?
Well, I mean, I haven't done biology since year 9, so I feel really out of my depth here. Can I go onion cell? Oh, that's not human, is it?
Onion cell.
That's all I remember from like year 7 science. Looking at, I'll be. I mean, there's the cell with the nucleus. I'll go. What about cheek cell?
Cheek cell. Okay.
All right, I'll go with that. I'll go with safe.
Is that memories of a certain practical in school?
It's just the one I can think of right away.
Fair enough. And Harry G.
I'd go with phagocyte.
Phagocytes, cool choice. Why?
I mean, who doesn't love things to do with viruses, and nothing better than a cell that eats them up.
So true, so true. Okay, mine is probably the red blood cell. Why? Well, honestly, I think there's an element of sense to it because back in the good, scary old days of year 7, I first learned of them as part of my first project in secondary school science. I'll never forget that the scientific name for them is erythrocytes because it seemed very much like this scientific fancy word that I had researched, and it's also the memory of making this 3D model I was so proud of, and it felt like the start of a novel world of discovery. Kind of sounds nerdy to me, but and you can probably tell I love biology.
Oh,
But
definitely.
these cells I do genuinely find fascinating because of their adaptations. Pretty much every human cell has a nucleus, Max.
Yeah.
Pretty much every human cell has a nucleus, and inside the nucleus is the very crucial helical or coiled structure called DNA. This DNA contains all the genes that make you who you are, and because it's in the nucleus, it makes the nucleus effectively the cell's brain. In a bit more detail, DNA is actually this big chunk of code that tells the cell how to make this stuff called proteins that actually do all the work. And that's the reason why eating protein-rich food is very important to a healthy diet. Life advice with Dr. X. eat proteins.
Oh,
But
I
the
like
strange
my
thing
meat.
about
Sound like my dad.
it's good advice. You should listen to it. The strange thing about the amazing erythrocyte, though, is that it has no nucleus, unlike almost every other cell in the human body. It means they have a lifespan of only about 3 months and need to be constantly regenerated. But ultimately, it's all part of the scheme generated by natural selection to help them carry out their function very well, which is to take oxygen where it needs to go around the body. So, like blood cells, each cell in the body is uniquely molded to complete their role as well as possible. This means there are loads of different types. So I have this other thing that I'd like to ask you guys. There are trillions and trillions of cells in the human body, but how many different types of cells do you think there are?
Like, is there as what kind of grouping are we going with? Because would you say that lymphocytes and phagocytes fall under white blood cell, and that is a type, or like literal different types that do different things?
That is a really good question. I think answer however you want to, because I'm going to mention both facts. But so a specialist, I guess, would say white bloods would separate lymphocytes from phagocytes. A non-specialist would probably say white blood cell. Any numerical guesses?
I mean,
20.
20.
I'm going to go my lucky number, 32.
32.
This is my lucky number.
Ooh. Ooh, we're going
I'll go with 40.
40 different types of cells in the human body. Well, a textbook would probably tell you there's only about 200 or 300 different types. But then a specialist like a neuroscientist might say there's actually 100 different types of nerve cells within your eye. And that's because they're all carrying out different functions while working in conjunction together with each other to carry out this bigger function as a unit. Okay, so some important terms now. Usually, lots of similar cells working together for one purpose are called a tissue, and different tissues come together to form an organ. So whoever was stealing all the toilet paper last year was clearly honing their skills as an organist. Sorry, I had to say it.
Oh.
But the reality...
You know what? It took me like ages.
Harry said he'd laugh.
Right. Yeah. So anyway, but the reality we're faced with is we don't know all the cells in the human body and everything about their adaptations. Most adaptations aren't actually as plain and obvious as lack of a nucleus, and scientists have so many questions, like how do cells form in the unique ways that they do? What genes control what? What proteins control? How do cells in a tissue work together to make you? And what diseases change what? Even though we know some grains of the answer to some of those, we don't know much. We don't even know every cell type in the body as of yet. But then comes in the Human Cell Atlas. The Human Cell Atlas. A very big team of world-leading scientists came together on the 13th and 14th of October 2016. All these experts convened to discuss and start plan for the Human Cell Atlas, which is destined to be a collection of detailed maps that describe and define the cellular basis of health and disease. In other words, they want to delve into the cell and create this enormous tool which has details regarding every single type of cell within a human man, woman, and child. The project is often compared to Google Maps because it shows you the actual position of each tissue in an organ and each cell in a tissue. And it will also show you how they work together to help forming you. But it's also got this element that's like being able to zoom in and seeing the cooler, finer, detailed structures and proteins that make up a human being. This is, of course, really ambitious, but the driving force behind this awesome new venture is the development of new technology and new methods for viewing cells in much more detail, using new experimental techniques that can tell us more about cells and can do it more quickly as well. But even with these developing techniques and technologies, it'll be a huge endeavor across the entire globe, and it will take many, many years before it's finished. Because remember, there are countless cells in an individual and so many little details that make each cell work. And different tissues that are each lots of different cells working as well, collaboratively. So this is a big project. So if you think on it, would it be worth it? Not only putting the work in, but the resources and time too. So what do you guys think? Would it be worth it?
Yeah, I definitely think so, because that would, I suppose, giving each cell a label would enable maybe more. I mean, I'm not a biologist, so
I mean, there's the cell with um, the nucleus.
I'm kind of giving my opinion here, but maybe it would improve development in science more quickly.
Yeah.
That I think it's definitely worth it. Is it
Yes.
similar to the kind of the organic nomenclature that is it like that, or is it?
Oh, in what sense?
Or like you could name pretty much every single organic compound somewhere
Yeah.
using the structures. Is it
Oh,
like
right.
that, or is it a bit more different?
Well, not really. It's different. Well, I mean, they're all cells, like organic compounds are all compounds and they're all organic. And in with organic compounds, you have functional groups, which are like special things which describe how it reacts. So I guess cells are similar in the fact that they have all of these special details, special ways that they express DNA, so that certain things happen differently in one cell to a different cell. So in a way, you could say that's a different functional group to a different cell. And then I guess you could also say if you were to classify like a group of cells like red blood cells or like a group of cells like white blood cells, then you could say that that's like a functional group, but then within that there are different types of compounds. So yeah, I can see that comparison. But the main thing is that the human cell atlas actually aims to try and describe how the individual cells work independently, but also how they come together in a tissue to work that way as well. And it aims to map every single different type of cell in the human body. But yeah, so I do think it's worthwhile because of its purpose and how its application can herd us into a better world of medicine. The atlas will vastly improve our knowledge of cells, yes, but the main element is the idea that a biopsy, which is a tissue sample some doctors might take of you, might just be compared to the cells that are documented within the atlas to check if it's healthy, or perhaps to more clearly let them figure out exactly what is going wrong and provide a swifter diagnosis. It's the potential ability to check for certain factors like a protein that is similarly essential in maybe one type of bone cell as it is in one of the eye's nerve cells, so they could predict the potential side effects of a new drug before they produced one. The idea of getting a clear understanding of diseases and cancers so we can see different factors causing issues like what gene will impact the cells most and ultimately help find solutions to those issues much quicker. But the project doesn't stop at medicinal impact either. Besides the aim to accelerate the development of techniques and technologies, there's a significant computer science investment to properly ensure the best data storing, filtering, sorting, and accessing methods are applied. And that access, by the way, is meant to be global, as in the whole world can see all of the data completely free of charge. Anyone can access it. And to make sure that Atlas is transparent, there's some data that's already been released for its first phase. Finally, the first paper for this atlas outlining the plan for it also highlighted its values, which the Human Cell Atlas Consortium deemed to be essential. The first is transparency, so data is openly shared instantly. Then there's quality of that data, which has got to meet standards that they establish rigorously. There's flexibility to adapt to new insights and technologies, and there's a focus on making sure it's a completely global community as well. Diversity, inclusion, and equity are crucial in terms of the cells sampled, and the privacy of research participants is also a priority. The last two values are technology development and computational excellence. So, to be frank, I think the whole project is incredible. Not only do I find it fascinating and look forward to its medicinal benefits, but it's also that the making of the Human Cell Atlas will effectively be a symbol of global unity. I think it's inspiring and refreshing knowing scientists and people from all over the world are working together on a global project for the benefit of everyone. So that's my piece on the Human Cell Atlas. Do you have any questions?
That's brilliant. And I'll be honest, initially I thought, is it worth doing this? But actually it really is, as you said, because it could significantly advance, having a database of of all those cells. So yeah, I think it's absolutely amazing. I was going to ask, what progress they made so far? Because I think you said it started in 2016. Do you know what progress?
That is a brilliant question. So from 2016 to 2017, that year they really spent planning it, and they produced this document that outlines their plans, which is called the white paper. It's brilliant. It's about 106 pages. It's freely accessible to anybody. You can download it from the Human Cell Atlas website's homepage, and it details the thinking behind the whole project and the steps that they want to take. So now it's about 2021 now, and so far they have started with the first phase. Obviously, such a huge project, you can't hope to do everything at the same time. But the first phase highlights certain organ systems and certain tissues and cells within those that they're going to prioritize first. And so there's research going on all over the world right now into those specific cells. There's actually a list of the priorities within the white paper, and some of those priorities include stuff like the heart, stuff like immune cells. There's a little bit of cancer research, I think. There's stuff on the brain. Even though they have limited the first phase to only a few different areas, it's still really diverse. And then there's also them trying to meet their goals, which is includes things like diversity. Also, at this initial stage, it's a little bit harder for them to try and make sure they can get cell samples from all these different ethnicities and people across the world. But they do have that in mind. They are trying, and they have all these regulations in place so that they can take in as much good data and diverse data as possible. Some of this data, well, as they get the data in, they release it. So if you go onto their website, you will be able to see documents on all of these different research projects that they've done so far. So this year, 2021, I know this like pediatric sampling thing. So that's like for children. If you can sign up by the end of March, I think it's the Chan Zuckerberg Institute starting this program where they can get samples, and that's a huge thing also regarding progression of the project. Actually, getting those samples from people all over the world, and that's really difficult. But obviously, like I said, if you're healthy, pretty much anybody can do it. They just need to find the right institute, and you can actually become a member of the Human Cell Atlas. So it's great.
Maybe I'll sign up. Yep. And last, but certainly not least, it's over to Harry to discuss about a new void, a strange void within our universe.
So, story time. I've done a bit of research on something I find quite fascinating because of its eeriness, and what can be more eerie than Boötes void itself? This is a spherical region of space that has a 250 million light year diameter of just nothing. It definitely lives up to its name of being a void. And I say it has nothing in it, but there are a few dozen galaxies here and there in a tubular pattern. Yet in a region of space this big, the galaxy count should be more in the thousands to 10,000s, because you can fit the entire Virgo supercluster inside of that, which is what the Milky Way is part of.
Wow.
It was discovered in 1981 by Robert Kirshner during a survey of galactic redshifts. And this void is somewhat unlike other voids in the universe, as most voids have a fairly uniform pattern of where they are, whereas Boötes is just a massive pit of darkness that just exists, and it's unsettlingly perfectly spherical. So it's quite creepy in a way, because there could be many theories, well, many science fiction theories as to what could possibly be in there. Astronomers believe that the size of the void came from many voids merging together, which gives a very strange image of voids being an entity that can absorb other entities, just like a black hole does. And given a void is the lack of anything, this is a really hard idea to get your head around. But this is where I found an interesting concept, where imagine that the universe is a foam. And all of the pockets of air that makes up the bubbles of the foam are the voids. And the lining of the bubbles that hold it together are galaxies. If you manage to break the lining between two bubbles, they'll merge to make a larger bubble. And this is the same thing that happens with voids. The preferred name for this structure is the cosmic web, because if you look at the diagram of our observable universe, you'll notice that clusters of galaxies are spread out, funny enough, like a web, with voids separating them. And by the way, a group of astronomers that worked on the Sloan Digital Sky Survey, which is the biggest redshift survey to date, believe that all voids were smaller a few billion years ago, suggesting that voids are continuously growing, which is pretty terrifying to think that somewhere, at some point, there might be a civilization in a void so big that it takes up their entire observable universe.
Wow. Yeah. This is sounding crazy already. Like,
Yeah.
this is like astronomy, proper astronomy here.
Yeah, it's I've just found it fascinating.
Yeah.
And just a little side point, I keep referring to the observable universe, and for those who don't know, this is a cool idea. That's the reason why we have no clue as to how big the universe really is. The observable universe is a spherical region around Earth from which light has had time to reach us since the universe began. And the boundary that separates this region from the rest of the universe is called the cosmic light horizon. Light reaching Earth from this horizon must have been traveling since the universe began, which is approximately 13.8 billion years. Therefore, the light must have been traveling for 13.8 billion light years to reach us. But that distance is not accurate in the slightest, as everything in the universe is always moving. So during this time, the object could have moved even further away and is still moving. Hence why, in our observable universe, it's only a snapshot of the galaxy. Of the universe, sorry.
Yeah.
Speaking of which, here's a fun little fact. Well, it's not exactly fun in a joyful way, more creepy and cool. But Boötes void is so big that, according to astronomer Greg Aldring, and I quote, "If the Milky Way had been in the center of the Boötes void, we wouldn't have known there were other galaxies until the 1960s.
Wow. Well, because the light takes so long to reach there.
Yeah.
Oh, wow. When did you guys discover galaxies? Do you know?
I'm not too sure, to be honest. I'm gonna take an absolutely wild guess and say in the Greek times.
That's what I would think. So yeah, that's a significant period of time.
Yeah.
Considering how fast light travels as well. Wow.
Okay, I have a question.
Yeah.
It's less science question. It's more like interested in your opinion. If you could like come up with this conspiracy sci-fi theory for what's in the void, what would it be?
Ooh, that's because that's very much limited to your imagination. Because you could literally put anything in there. I like the idea of an absolutely massive, like, galaxy supercluster size, takes up most of the void, space monster, which skin acts as black holes, so it absorbs all light incoming. So that's why it appears so like there's nothing there.
Oh, nice.
That's what I'd go with.
How do we know it's not like just a big planet that's black? Just like massive or painted black.
Yeah.
I mean, think about the gravitational pull of that, though.
Oh god, yeah, that would be quite big.
It's true.
Yeah, I don't do physics, so I've never even heard of this. So where did you like come across this?
To be honest, I actually don't remember when I came across this. Yeah,
Really
so I have
interesting.
I've known about it for a while, but I haven't actually researched up on it until recently.
Well, that's absolutely brilliant, Harry.
Yeah. Also, as a fun little side point, I did some conversions because why not? And this is really random, but I thought it was a bit interesting, which is that the average person runs at 12.8 kilometers per hour, and Boötes void is 2.3 times by 10 to the power of 21 kilometers wide. So that's the 250 million light years converted into kilometers. And it would take 1.8 times 10 to the power of 20 hours to run. And there are 8,760 hours in a year. So it would take 2.1 times 10 to the power of 16 years to run. You would be about 20 quadrillion years old if you ran from start to finish of it.
That's like
Which-
almost half my lifespan.
Yeah, I mean, maybe even less.
I wish I started earlier.
Yeah.
When you get to the end, I guess you're just skin and bones.
I think it'd be less than that.
Yeah.
Although, actually, if you think about it, because you're in space,
Yeah,
if, if you don't go too close to any stars, you wouldn't actually, what's the word? What's the word? What's that when you break down?
decompose.
Yeah, that's it. You wouldn't actually decompose. Or would you? No, because also it's so cold that you would technically be frozen.
Yeah,
Okay. Yeah.
that's kind
So
of.
unless you got close to a star, because I mean, if you, oh no, but yeah,
Maybe they should. Maybe we should do an episode where one of us talks about all the different ways you can die in space.
that'd be quite interesting.
Joyful.
That will probably take a couple of days.
Yeah. Finally, scientists believe that voids are absolutely full of potential, and that potential is dark energy. The theoretical force or energy that causes the universe to expand at an accelerated rate. Sadly, I don't know too much about dark energy, and as it's a completely different topic, I'm going to leave it for the next episode as a nice little sequel to this.
Ooh.
That's all from us today. Thanks once again to Harry, Zaynah, and of course Dr. X. Remember, be sure to like, subscribe, check out our other videos, and please share the video. Thank you from us, the Sci-Cast, and goodbye.